Hello, everybody. This is Professor Ma, and this is the introduction to the sections on ellipses. We had the conic sections, which are cross sections of cones, and we have these four different types. And there, the equations associated with them are the second degree equations. And we went through circles, and now we're going to take a look at the second type, the ellipses. Now, the equation circle can be simplified into the following forms. The equation of circles where the coefficient in front of the square terms are the same. So I can change both of them into one by dividing through. So if I have equations in this form, then we get a circle. However, if I change, for instance, let's fix the x, but if I change the number in front of the y squared, instead of 1, I change that into a number r, which is positive. Okay, and then I will get ellipses. In particular, the R controls the how we can stretch a circle in directions of y, because now the R is coefficient in front of the y squared. How can we stretch that into ellipses for this type of equation, that is 1x squared plus some positive r squared, ry squared. Okay, and so the R controls the compressions or stretch factors. So we'll see that at the end and how it works. But let's talk about the equation of ellipses. First, what are ellipses in mathematics? Ellipses, basically, we start out with two fixed points. We call this fixed point foci, one focus, two foci. And the ellipses consists of all the points on this web ellipse. And what do they satisfy? They satisfy the following conditions. So if I arbitrarily choose 3 points over here, okay? And then the requirement is the sum of the distance to the foci. So if I standing at a point P, I measure how far I am from, or how far is P to the first focus, F1, that's the P1, and then I measure how far is to second focus, that's P2, and I add up the sum. And ellipses, the sum, they are the same for point P or for point Q or for point R. Okay, so the sum of the distance to the foci A is a constant. And ellipses comes in two types. One is, if you think of a circle, okay, one is, I'm going to stretch up and down the y direction. So you can think of a circle, it will squash the circle in the y directions, always stretch the circle in the y directions. But they all have a centers, kind of like this, like the centers plays the same role as a center for the circle. And then there are 2 points, which are the two foci, okay? And we have 2 axes, and the longer axis is sometimes called a major axis, and the shorter one's called minus axis. What we are going to use, we're just going to use the radius in the x directions and the radius in the y directions to graph the ellipses. Okay. Now we're going to use complete square again, and we're going to put the second degree equations into a standard equation for ellipses, which is this. Okay. How do we decipher this? So any equations of the ellipse, you can use we can use completing the square and manipulate the equation into this standard form. Once we have this standard form, and this is how we identify the major component of the ellipse. Okay, the HK will be the center, A will be the horizontal radius, and the B will be the vertical y radius. Okay. So for example, for these equations, it's in the standard form of an ellipse. Notice, first of all, the standard form of the ellipse, we have to synchronize the right-hand side to be 1. We'll see how we do this in algebra shortly. But if suppose it's 1, then everything's all set, then you can identify the center. Okay, 3 minus 1. And the x radius is 4, y radius is 2. So we can identify those. And these are the basic component we need to graph the ellipse. And this, we're not going to do any further than that. Okay. And there is formula to figure out what is the fold size are. But we're not going to do that. Okay, so we're just going to graph the center, and we're going to graph the 4 cardinal points. Okay, x radius 4, y radius 2, and we graph the 4 points, and then we just shape the ellipse. Okay, so this is how we're going to graph it, provided we have the equation in this format. Okay. Now the next is, well, next thing is how do we manipulate the equation into this format? Basically, it's a format related to concerning distance. Okay. And concerning the compression ratios, stuff like that. So here we had demonstration how we're going to put these equation of ellipse into a standard form. First of all, how do I know it's ellipse? Remember, as long as they have the same sign in front of x squared, y squared, but different numbers. If the same number is a circle, the numbers are different, but both positive. Both negative can divide by negative, then they become positive, right? So as long as they have the same sign, it's an ellipse. Then we can manipulate this equation into that standard form of the ellipse. How? So here comes the algebra trick using completing the square to put into the suitable format. Okay. First, you group the x, you group the y. And in order to complete the square, we have to have only one x squared. In other words, I need to pull that 9 outside. Okay. And same thing, and pull a 9 out of 18 will be 2. Okay. You say, what happens if this is 18? Some numbers like not very good. It's like for example, 4. Well, then we are stuck with 4 over 9. Okay. So in fraction terms, then we have to deal with fraction. But this one we don't. Okay, and then you leave a space. We're going to park a number over there for completing the square. Okay, and do the same thing with the groups of y. Then we complete the square. Okay, and notice to complete the square for the x, we add a 1 in the parentheses. For the y, we add a 4 in the parentheses. But the parenthesis is multiplied by 9 for the x. So in reality, we added to 9. Altogether, we didn't just add 1. Okay, over here it looks like 1 inside, but altogether the 9 parentheses. So altogether we add a 9. In other words, on the other side we compensate by 9, and likewise in the 16. So this is the algebra you have to watch out for ellipses. Okay, and yeah, this is basically where if things goes wrong, it goes wrong right here. But once we pass these steps, then we can put that parenthesis as a linear square. And then notice I want to now synchronize the 36 to be 1. Oh, I divide across by 36. Okay. And then do some cancellations. In this type of problem, usually the algebra will come up clean, so you have a nice looking standard form, which we can identify the center, which is in this case 1, 2. I guess what is where we use. Okay, and so this is the plot. Okay, again, for the homework, you need to plot the full cardinal points. Okay, now let's go back to the equation. Remember, we said in the case where the r is positive, okay, if r is 1, we get circle, but if r is not 1, but same sign, then we get a stretch ellipse, stretch circle, which are ellipses. How? Okay, let's use the equation center 0, 0. Okay, so if r is 1, I get a circle. Okay, if r is 1/4, okay, notice this is what we meant by that is 1 y/2 squared. Okay, in other words, this is 1/2 times y. Y is replaced by 1/2 times y. And if you remember from translation of graph, then the stretch factor is the reciprocal, is 2. In other words, then every point on this gets stretched up to twice as far. Okay, so therefore the whole thing is stretched by 2. Same thing for 1/9, and gets y direction gets stretched by 3. On the other hand, if the number r is more than 1, like it's 4, then that is square of 2y. The reciprocal 2 is half. Hence, I squash the circles, and same thing with a 9 there. So that's what we mean by that. R is a compression factors, and this is the formula for that. Okay, you can check that easily. Okay, and that's it. Bye-bye.